In this section, we'll be looking at terminal points, more specifically, how to find terminal points given certain pieces of information. This is part B, which is terminal points on the unit circle. Throughout this section, and to be consistent with the book, we'll refer to a point on the unit circle by the following notation. And we'll call points that lie on the unit circle terminal points. The connecting factor between terminal points and right triangles is going to be angles. And it turns out that an angle is always going to determine our terminal points. To see this, let's go ahead and sketch out a picture that maps out our current idea. Suppose we're given the following unit circle. And we have a point on the unit circle. Then if we draw a ray connecting the origin to our point and the origin to the point 1, 0, then we just defined an angle between the point xy and the point 1, 0. This angle is always going to uniquely determine our terminal points if the angle is between 0 and 2 pi. So let me write down my air quotation, and that is the fact that terminal points are determined by angles. And in the book, we say that a terminal point is just determined by the number t. Recall, by convention, an angle that's measured in the counterclockwise direction is always a positive angle, and an angle measured in the clockwise direction is a negative angle. Common angles are going to correspond to common points on our unit circle. Let's look at the 4 cardinal points on the unit circle. In this example, we want to find the points that are associated with the angle 0, pi divided by 2, pi, 3 pi divided by 2, and then again 2 pi. The measurement of these angles is given in radians. For theta is equal to 0, we're going to first draw our unit circle. So here's our unit circle. Then an angle 0 is given by a ray, initial ray that points in this direction, and also the terminal ray that points in this direction, which means the associated terminal point is going to be 1, 0. For the terminal point determined by pi is equal to 2, we can go ahead and again draw the angle. The angle determined by pi is equal to 2 looks like the following. Then the terminal point associated to pi divided by 2 is the point 0, 1. We have 2 more terminal points. Let's look at 3 pi divided by 2. Again, we need to draw our angle. Here is our initial ray. Here is our terminal ray. Our terminal ray intersects our point. And this point here is given by 0, negative 1. Then the terminal point associated to the angle 3 pi divided by 2 is again 0, negative 1. Finally, the last one, we're looking at 2 pi. Again, our initial ray is on the x-axis and our terminal ray is also on the x-axis. This means that the point that's determined by 2 pi is again 0, 1. On the next page, we're going to list more common terminal points that are going to be useful. Again, in the first column is going to be our angle, which is theta, and the notation they use in the book is t. We'll be looking at the angle 0, pi divided by 6, pi divided by 4, pi divided by 3, and pi divided by 2. When we have 0, we saw in the last example that the terminal point p of x, y is going to be the point 1, 0. Pi divided by 6 will be given by square root of 3 divided by 2 and 1/2. Pi divided by 4 is given by the square root of 2 divided by 2 and the square root of 2 divided by 2. Pi divided by 3 is 1/2 square root of 3 divided by 2. And in the previous example, we saw pi divided by 2 is 0, 1. So we know how these 2 points arise. And in the next section, when we introduce right triangles, we'll look at the reason why these points lie on the unit circle. But one thing to notice is that every point on this list is going to satisfy the equation 1 plus x squared plus y squared. Oh, excuse me, this should be a 1 is equal to an x squared plus y squared. Now, given these common terminal points, let's find some more terminal points determined by coterminal angles. And also angles that aren't in the first quadrant. Example 2, find the terminal points determined by the following angles. In part A, our theta will be equal to 7 pi divided by 6. And again, in the book, the notation is t is equal to 7 pi divided by 6. Part B, we'll be looking at theta is equal to 3 pi divided by 4. Again, the book notation says t is equal to 3 pi divided by 4. Starting a new page, we'll look at part A. Let's begin by drawing our unit circle. So here's our unit circle, and the angle that we were given was theta is equal to 7 pi divided by 6. We know this angle here is pi, which means that 7 pi divided by 6 is going to be in the third quadrant, somewhere over here. First, since we're looking for this point P here, again, we're given that this point is determined by 7 pi divided by 6. And in this case, in the picture, we see that 7 pi divided by 6 is going to be the same thing as pi divided by 6 plus pi. What this means is the angle between our blue ray and this red terminal ray right here is pi divided by 6. By symmetry, we know the coordinates for the terminal point that is determined by the angle pi divided by 6 in the first quadrant. And this point here was given by square root of 3 divided by 2 and 1/2. Again, by symmetry, our red point over here is going to have the same values as our blue point in the first quadrant. This means that the coordinate values for our red terminal point P of xy is going to be equal to the square root of 3 divided by 2 and 1/2. But since we know our point Pxy lies in the third quadrant, our square root of 3 divided by 2 is going to have a negative in front because it's a negative number, and then we're going to have a negative 1/2 here because it's up below the x-axis. Now let's go ahead and look at part B. In part B, we're looking at the terminal point determined by the angle 3 pi divided by 4. 3 pi divided by 4 is less than pi but greater than pi divided by 2, and this means the ray of our angle, the terminal ray, is going to be in the second quadrant. Then what we can gather is the remaining angle over here is going to be pi divided by 4. Again, by symmetry, what we know is that pi divided by 4 in the first quadrant corresponds to the point square root of 2 divided by 2 and square root of 2 divided by 2. Then, by symmetry, the terminal point that corresponds to 3 pi divided by 4 is going to have the same coordinate values, square root of 2 divided by 2 and square root of 2 divided by 2, where we place the correct signs. So in this case, our x value is either going to be plus or minus. We need it to be a negative sign because it's on the left-hand side of the y-axis. And our y value is going to be positive because it's above the x-axis. So the point P of xy, which is determined by theta is equal to 3 pi divided by 4, is the negative square root of 2 divided by 2, square root of 2 divided by 2. The method used to solve this problem works in general. Let's go ahead and outline how to find points on the unit circle. The method used in this problem will work to find points on the unit circle given certain angles. Let's go ahead and outline what we did in these problems. First, we need to find the quadrant where the terminal point is contained in. Then, draw a ray between our terminal point and the origin. The ray in part 2 determines two angles, each at which start at the x-axis. Choose the smaller of these two angles. Let's call this angle theta prime. The angle theta prime is going to be between 0 and pi divided by 2, which means that theta prime determines point coordinates from the list that we saw before. Then the point P of xy has the same number values as P prime of xy. The last step is we just have to make sure that the signs are correct. So even though we've written this out, we'll see that we can simplify this entire method in the next section. Let's go ahead and determine one more terminal point given an angle. This is example 3. Find the terminal point determined by the angle negative 5 pi divided by 6. To start off, again, let's go ahead and draw our unit circle. This is a negative angle, which means that we're going to measure in the clockwise direction. 5 pi divided by 6 is still between 0 and negative pi, which means that the angle is going to push our ray to be in the third quadrant. Now the remaining angle between our ray and the negative x-axis is a negative pi divided by 6. The point that's determined by pi divided by 6 lives in the first quadrant again. And the value of this point is given by the square root of 3 divided by 2 and 1/2, which means the value of the point determined by negative 5 pi divided by 6 is going to have the same component values as this number here, but the only thing that's going to change is the signs. Since our x value here is negative and our y value here is negative, this means that the signs for this point here is going to be given by a negative square root of 3 divided by 2 and a negative 1/2. And this is the values for our coordinate, or sorry, our terminal point.